Hi, my name is Helge Maus from pixeltrain. In this second part of my tutorial series about motion graphic techniques inside of Houdini, we want to talk about points, point movements, trails and plexus effects. In this first tutorial, we want to talk about point generation and how we get points moving in space. So let us start. We go into the scene view and we add a GeoNode to our system. Then we dive in and delete the file node here. The first thing we need for our experiments is we need some points, and for this I generate a platonic object and change the appearance, for example, to an octahedron. So we get some points. We can remove here the grid for a moment. If you hold on your middle mouse button, you see the informations about this node, and you see in the moment we have 6 points here, which are the basic points for this octahedron. We need a whole bunch of more points. For this we can use, for example, a subdivide node to get subdivisions here, but you also can use the scatter node. The scatter node places points, for example, on a surface. You see the points spread out here. And if you hold down now your middle mouse button, you see we have 1000 points. The amount of points is something you can give the scatter node here with a force total count. And like I've said, it uses in the moment the surface of our object. Because we work now much with points, I want to change a little bit my viewport. Go over the viewport, hold down the D key, and under geometry you can change here in the particles section the point size, and I give them a point size of 5, and you see the points are now much thicker. And also we can go to the background and change this, for example, to dark. Okay, interesting. We've changed an option for particles and our points in our viewport have changed. Houdini doesn't really differentiate between points and particles. Particles are points which have more attributes, but under the hood, particles and points are really the same. And so for our experiments now of moving points, we can use these points which are generated through the scatter node. But first, I want to show you some options of the scatter node. In the moment, we have exactly 1000 points on the surface, and these points are really equal spreaded. The reason for that is that we have here in our scatter node a relaxation area, and if I remove the relaxation for a moment, you see if you really want to have random points on the surface, you can deactivate this, and these are really random points. To make them evenly spread out, we have these 3 options under relaxation, and the first step you normally take is you have here radius of the relaxation. And the whole relaxation process runs more than once, so we have iterations. And the more iterations you have, the more equal spaced are the points. Takes some time, but yeah, it looks better if you need something equally spaced. Also, you have here a global seed. If you don't like the pattern you get, you can change the global seed. And yeah, we've talked about the amount of points. There are many more options here, but in our case, for our experiment, maybe we later want to change that we don't only generate points on the surface, we also want to have points in the volume. For this, you have to give the scatter node not a surface, but a volume. To get a volume out of the platonic, you can use the ISO offset node. If you hook this up and bring it to the display, you see this little fog volume here, and if you hold down your middle mouse button, you see instead of a whole bunch of points we had before and primitives or polygons, we have now only 1 point here, but we have here a voxel grid, and that's exactly what a volume is. A volume is made out of voxels, and we have 1000 voxels here, and they are represented in the moment here by this fog volume. If you want to change now the details of this, you can go into this creation process here and change the uniform sampling divisions. The more you have, the better you get your surface represented as a volume, but you also get more and more voxels, which takes more time. But these informations now can be used for the scatter node now to place points in space, and you see exactly what you need. Now you have points in the volume. So two options we can use here. If you want, we can use them both together. So for this I use a switch node, and in the switch node I hook up the way directly. So if you have select input 0, you get only the surface points. If you want to use this ISO offset as an input, you can also add this to the switch node. Lay it out a little bit nicer. Okay. And to switch now, you only have to switch the input to input number 1. And now you have these points here in the volume. Okay. So now we have the points. We want to have some point movements. The first idea most of my trainees in trainings have, if we talk about point movements, are particle systems. Particle systems are a really strong area of Houdini, but they take time. You have to experiment with pop forces and so on to get a nice movement. Sometimes this isn't necessary. And so I want to show you now two ways of moving these points or particles around. The first way needs only one node. It's the spring node. The spring node is like a whole simulation system in itself. If you hook this up, I switch here to real time so that we have a real-time representation of the timeline. You can add here through these inputs here collision objects and also external forces. But if you don't hook them up, the spring node itself has a forces tab which we can use now. Inside here we have some standard forces, and here we have a turbulence. If you hold down now the middle mouse button over turbulence and add a little bit with the value ladder and press now the arrow upwards or play, you see that the points now move in space, and this looks really cool. So we have now organic movement without a big particle system, and this is one way of changing point positions in space. In the next approach, we want to build our own movement generator, and for this we use a point warp. One question which are always important in my trainings about Houdini is, when do you use which kind of warp, and what is the difference between wranglers, warps, and all this stuff the Houdini users all the time talk about? The easy explanation of this is you normally code here inside of these streams with a language which is named VFX, and VFX gets more and more used inside of Houdini. You can code it by yourself, so you use wranglers, and if you want to have a visual coding environment, this is named a warp. If you have added a warp node, you can make a double click and you have here this visual scripting here. Under the hood, it generates really VFX code. You can see it if you hold down the right mouse button here, VFX and warp options. You can see the VFX code here, which is generated. And if you added your own nodes, you see them here and how they are hooked up in the VFX. And in the moment it runs the first time, it compiles and it runs exactly the same speed like a Wrangler VFX code. But the difference between these different kind of wranglers and different kind of warps is on which components they run. So if you make a point warp like I did, you see here that the run over statement here inside the warp is points. That means it takes every point of this input here and it manipulates every point with the script which is inside of this warp. If you want to have, instead of a point warp, a primitive warp, you only have to go here and say, now I want to run over primitives, and now you have a primitive warp. So most warps are really the same. The only thing is that you have to change here the run over statement. Normally they run over every instance, for example, points, vertices, primitives. but there is also something like detail which only runs once. And then there are also some special WOPs. For example, a volume WOP here is normally used for volume manipulation, so the data inside of voxels. So if you have added now your point WOP here, we can dive now inside of this, and I switch back to points, otherwise it doesn't work. And the whole programming here is visual. So you are inside of a wax builder. On the left side there's a node which is a WOP global node. So if you add here global, for example, you see you can have some global nodes here where you can get informations of objects and the inputs. And on the right side here there's one output node, which is also something which you can add by yourself. And if you now want to manipulate, for example, all these points, you can override attributes which the points have in the moment, position, the velocity, force, CD is the color of the points, the normals, and so on. So you can add your own attributes here if you like, and if you have attributes which come in but they are not represented here by one of these slots, you can add here a bind node which gets information into the system. But this is a topic we talk about later. If we now want to move these points, I can use a special kind of noise. And here are a whole bunch of noises, and we can use, for example, a curl noise because it looks nice. This curl noise here is a Perlin noise here. You can change the signature, so it's a 4D or 3D noise. You get here different parameters, and here you get the information out. And if you take a closer look, you see different colors. And here in this lower part of my wax builder, you see a little command. So if you go over here a port, you see the name of it and the data type which it is. For example, age is a float value, or here if you go over position, it's a vector. And so you normally connect the data types which are correct for each other. Wax is able to convert some of these data types, and there are also a whole bunch of converters which you can use to convert these data types if you need them. So if we have, for example, now our curl noise here, we have here our noise, and the noise here is a vector. And if you like, you can hook up the vector here, for example, with, let us say, the position. This looks terrible. What has happened? You see, all our points are now at this point here in space. They are still there. You see them in the geometry spreadsheet. If you go to the points, you see here are all the points, but all the points have exactly the same position in space. The reason for this is that this curl noise here delivers a 3D pattern, and all the points have the same values, and so this noise delivers the same value outside. So you have to change something, and something which is different between every point is the position where they are normally in space. And for this, you really often see that you take the position and add the position here to the curl noise itself. And now every point is moved to a different location in space, and this is a representation now of this curl noise here. So if you change here the type of the noise, you see exactly the noise types. And yeah, this is not what we want, because on the one side it's static, and the other thing is, yeah, the original position is gone. So you see, if you change the amplitude here to 0, you see normally all the points are here at the same, and yeah, this is exactly the representation of the noise. Our original positions are gone. We only want to add this curl noise to the original positions, and for this we can use the add node. And this add node here is like in a normal formula. You can add something to it. But one thing is important. You see that the ports in the moment are white. White means neutral. They are not really set which data type they have. And this is really nice. These arithmetic nodes inside of wax look into the first input they get to change the way they work. For example, if I take here the position now, which is a vector, and add the vector here to this input 1, you see now the output is also a vector. And so it's important that you decide which data type you need. So I add now to the original position, you see this is the original position, the output of this noise. And now you see chaos. But if you go now here into the amplitude and bring it down, you see it comes really from the original position. And this value here is something we want to change later. It's the amplitude here. If I want now to animate the whole thing, if you press play, you see nothing happens at all at this point. I have to change something in the kernel noise. And typically for this here, we change the offset. If we now change the offset, you see that the whole noise is now moving and it looks really nice. It's like our spring node effect. To change this, we need something which in the scene always changes, and for this we can use the time here. And if you take a closer look here on the left side, you see we have on one parameter here the time, it's a float value, and on the other parameter we have the frame number, and both are changing if the animation runs. And if you make a direct connection between now the frame number and the offset, you will see that you get an animation, but it's extremely fast. Okay, because the frame number really changes a lot. If you like, you can say, okay, let us try the time. It's a little bit slower, but still too fast. So what I want to do is I want to multiply this here down, so that's not so fast. And for this, we need a multiply node. Remember, we can change the data types by inputting. You see, here, this is the same, but the product here is normally a float. Offset is a vector normally, and it shows, yes, I do this, but it's not exactly what you want. Yeah, so you get a casting here of this float to this vector. But this multiplication here needs another input, and we don't have one. So we can use a constant node. I place it here on the left, and I tell the constant node it delivers a constant of 1. It's a float value, and I deliver this here in. So if you now press play, you see it works. If I want to slow it down, you can change in the constant node here, the constant which we deliver, and it gets slower. Nice. The same construct here I want to use here behind the kernel noise. So I want to output here an amplitude of 1 always, but then I want to have a parameter here which multiplies it down. To make a bigger window, you can use your Control key or Command key and press Command or Control B over this window, so you get a full screen. Let me make some space here. I use a multiply node again. I want to multiply the output of this here before I add this. And for this I need another constant. And I hook this up at this point. And this time we have here a slider which we can use to change the amount of noise we want to use. So if I look here, no change at all. And if you go now to the constant here, you can add a little bit of the noise here by multiplying it up and down. Okay. And so you see, we now get a more and more complex system where we can change now here the speed of our movement and also the amount of noise we want to have. If we go now outside of this WOP, this is a black box, a container. And this is a problem if someone wants to use now this attribute WOP without knowledge how VFX inside works. So what we can do is now we bring out these attributes which are important for us to the interface here of this attribute warp. You've seen something like that in my first series about the rasterizer, and on this knowledge we now build. So I go into this here, and if you want to bring something outside, you have to promote this attribute. We start with the curl noise. If you say, okay, I want later to change the noise type here, because this is really interesting that you can have here different kind of noises, you want to promote this field. To do this, there are several ways. One way is go here to this little cogwheel and select Promote Parameter. The moment you do that, it's grayed out here. You see that's promoted. And also you get here this little flag here. And this little flag here you can select because it's a node, it's a parameter node, which is collapsed here on the input. And if you select this, you see something which you have seen when we built our own user interfaces in the last tutorial series. You see here's noise type and you get all the parameters here. And if you go now out, you see on the WAP node itself, you see now here a user interface drop down where you can change the noise type. This is one way of doing it. A faster way is you go here over the inputs which you are interested in. For example, I want to change here the frequency, so make a middle mouse button click here on this input and say promote. And so you get all the parameters. Also the roughness. I want to have the turbulence value here. And if you have tested all this, you can also add more stuff here. Here the attenuation. Also this parameter here. This is good. And so we have now a whole bunch of new parameters here on this warp. Also, we had two parameters added here. You remember we have a constant here for the amount of change and also here a constant for the timing. I said that these here are collapsed parameter nodes. So if you want to bring something out, you can use a parameter node. You see, you can add this. It's a yellow node here. And I want to use now this parameter node here. If you select this, you can have a name for this. So this here is, for example, speed. And the label is something you see as an artist in the UI. So this is the speed multiplier. And here's a default value, for example, it's 1. If you have added this, you can remove this constant node now, go outside, and now you see here on the warp, you have here your speed multiplier. And if you now press play, you can change with this here the speed of your point movement. Great. Same here at this part, so remove this. And if you want to have a parameter here, you can hold down your middle mouse button, promote parameter. Like I've said, it's the same here. If you select this, you can change the label. And this is the noise multiply for us. Okay, that's it. Now we can go out here, go here, change the noise multiply to 1 or 0.1. And now we have a whole movement generator for our points here. This closes now the first tutorial. I hope you learned something interesting, and if you have questions, drop me a mail. My name is Helge Maus from pixeltrain. See you in the next lesson.